Okay, so the question is about the chapter sequence and series. It involves few concepts of complex numbers and the sequence and series. The prerequisites of this question is to know about the basic concepts of Q roots of unity. So the properties which are going to be used, I'm mentioning now. First is that sum of complex nth root of unity is equals to 0, and omega raised to power n is equals to 1. The given expression is r is equals to 1 to n. A r plus b into omega r minus 1. First we have to just expand this expression. We'll just put r is equals to 1, r is equals to 2, r is equals to 3. After putting r is equals to 1, we'll just get a plus b. Putting the value of 1 here, we'll just get omega raised to power 0, which is just means 1. Then we'll get 2a plus b. Putting the value of r equal to 2 here, we'll just get omega raised to 1. Then omega normal omega. Then we'll just take this series further. At r is equals to n, we'll get this expression. First of all, please realize that in the end, b is also being multiplied by omega and a is also multiplied by omega, so we can just break it in simpler terms like a 2a omega and b omega. Since there are as many terms as b omega, so we'll just separate the terms of a and b. First I'll uh, expand some for better understanding. Hmm. Now we'll just take b term separate and a term separate. From that we'll get b, this, and then this, b plus omega, then omega square plus then omega n minus 1, then a 1 plus 2 omega, 3 omega square plus this term n omega raised to power n minus 1. As I discussed above, that sum of complex nth root of unity is equals to 0, and this is the sum of complex root of nth unity. This just means 0, and if b is multiplied by 0, it will just mean 0, so this whole term is 0 now. 0 plus a 1 plus 2 omega plus 3 omega square plus n omega n minus 1. Now if you observe a little, you will understand that This series is nothing but a arithmetical geometric progression, and there is a standard way to solve it. Since these are all in addition, so we'll assume, I mean, there's no need to assume, but we'll assume that this is the summation, and omega n minus 1. So the way by which we can solve arithmetic or geometric progression, we just need to multiply the variable which is here, the omega, both side. So now we'll get another equation which is omega is 1. We'll multiply 1 by omega, then it will become omega, then 2, then it will become 2 omega square, then 3 omega cube. Hmm. And we'll write it till n minus 1. N minus 1 is what? Second last term. Omega n minus 1 plus n omega n. Since we multiplied omega, so here it will just mean that multiplying omega and n minus 1 into omega will just mean adding 1. So this one will cancel out and this will come. Now we'll just subtract these two equations. Subtracting, or we'll take as common, so it will just become as 1 1 minus omega. This one will remain intact as there is no constant here. 1. We'll reduce uh, omega from 2. It will become omega from this to this plus omega square plus so on till omega n minus 1 minus n omega n. Okay, so now that I have already mentioned it, that what is this? This is just sum of nth cube root. Like, isn't this expression and this expression similar? Then it will just become 0. And as I mentioned earlier, that the omega n here is equals to 1. So after applying the properties, we'll just get minus n, 1, which will just mean minus n. And s1 is equals to minus n upon 1 minus omega, or we can say n upon omega minus 1. And to convert it in more general term, we can say s is equals to n a omega minus 1, and this is the answer. S is equals to na upon omega minus 1. Hope you understood.